Hello, so today we're going to be looking at transition matrices. Now, I have written some success criteria and we're going to go through that step by step and then we're going to apply it to a question. So the first thing you need to do is you need to work out what the initial state is. Now, in matrices, the initial state, which I've written in blue, is called SO. So that is what is currently happening. Then we're going to construct the transition matrix, which is in green, from the information that we're given in the question. And that's generally talking about probabilities, where the initial state could be talking about the number of people or probabilities. Then we're going to calculate the information that we are requested in the question. What we need to remember is the initial state, which is SO. That's where we are at day 0. Then we're going to use a transition matrix. So if it's just t, that's at the end of day 1. If it's t squared, day 2, t3, day 3, t4, day 4, or month 4, or whatever period you're working in. It could be days, months, hours, years. It doesn't actually matter. But the key thing you need to remember is SO is the initial state, so starting point day 0, and then the T1, that is at the end of your first period, T2, second period, T3, third period, and so on. Now our final point is point 4, which is calculating the steady state, which is shown in red on the success criteria. Now basically, the steady state is if everything stays the same, what's going to happen in the end. So if we keep going on the trajectory that we are on, what is the probability of different things happening? Now there's a really straightforward way to do this using your graphical calculator. You get your transition matrix and you put a really high power in there, and that will work out your steady state. It could be 100, it could be 1,000, it could be 10,000, but you will know when it is, and I'll demonstrate this when we're going to go through, because all your digits, so 4 decimal places, will be the same for both columns. So that's how we go about doing the steady state. Now we're going to start going through the question. So at a local high school, 30% of the students who bring their lunch from home on day 1 will buy their lunch at the canteen the next day. So that's our first piece of information. The second piece of information is 50% of the students who buy their lunch at the canteen on day 1 will bring their lunch from home the next day. So what we're going to do, we are going to have a look at the question. It says construct a transition matrix T for this situation. So this is jumping straight to step 2, and we're going to do our transition matrix. So for A, we are going to first of all look at what we've got for lunch today. And today is going to be in this way, and then lunch tomorrow is going to go here. And what we're going to get, if we draw a little grid, we've either got here, so at a local high school, 30% of students who bring their lunch from home on day 1, so today is home, will buy their lunch at the canteen the next day. So we've got home and canteen, so H and C. So 30% of students who bring their lunch from home on day 1, so home today, will buy their lunch at the canteen the next day. So we're going to put 0.3 in there because that's 30%. Now we know out of those students going along that row, we have got 100% or 1. So we would know that if 30% are going to buy their lunch from the canteen tomorrow, if they've brought lunch from home today, we know that 70% of the students who bring their lunch from home today will get their lunch at home tomorrow. So that's our first part of the transition matrix completed. We then look at the next line. 50% of their students who buy their lunch at the canteen on day 1 will bring their lunch from home the next day. So here we know that this is a canteen today, and 50%, so 0.5, are going to bring their lunch from home. We know that adds up to 100%, so 1, so that'd be 0.5. So we can say our transition matrix is 0.7, 0.3, 0.5, 0.5. And what we've actually got to do, we've got to make sure we put our square brackets in there to make sure it works. So that is part A completed. We're now going to have a look at part B here. So on Monday, this is looking at our initial state. On Monday, 400 students from school were surveyed and 243 brought their lunch from home. So what we're going to do, we are going to start having a look and we are going to work it out. So for part B, we have got 400 people in the school and we know that 243 of them brought their lunch from home. So if we stick with the home and the canteen, this will give us our SO. So we're going to write in here what we've got. 243 bought from home. And we know 400 minus 243 is 157. So we know that 157 bought their lunch from the canteen. And that is our SO. Now for part C, the most important thing that I want you to remember, Monday, which is our initial day, that is day 0. So Monday is day 0, so that is our SO. Tuesday is day 1. That makes Wednesday day 2. Thursday day 3. And Friday day 4. So that is really important, and I think that's probably the point where most people go wrong. So we know that day 0 is our SO. So if we go here, we know that our SO is our 243 and our 157. So we know on the first day of day 0, so Monday, we've got 243 students who have lunch at home, and we have 157 students who will be getting lunch from the canteen. Now in the question we're asked about Tuesday. So Tuesday would be S1. Now to put S1, that's our first day after day 0, what that means is we've got SO multiplied by our transition matrix T. Now bearing in mind we don't need to put to the power of 1 because that is just the same as T. But if it helps you to remember, you can put the little 1 there because it's the first day. So for our transition matrix, we are going to have our 243, 157, and that is going to be multiplied, and we don't need the multiplication sign, by 0.7, 0.3, 0.5, and 0.5. So we are going to multiply these together, and that will tell us how many students we expect to buy lunch at the canteen on Tuesday. We're going to work that out. Now, because I am a little bit lazy, I am going to put this into my graphical calculator, or I'd say efficient, and I am going to put that in. So I'm going to put this in as Mat A, and this one here is Mat B, and I'm going to do Mat A times Mat B using my graphical calculator, which is a Casio, and that would give me 248.6 and 151.4. Now we're actually talking about students. So bear in mind when we're talking about students, we don't actually want 248.6 and 151.4. A much nicer solution is 249 and 151. So we round mathematically to the whole number when we're talking about individuals. So that is how we would work out how many people we expect to eat at different places. And remember, we're keeping everything in the same order. So we would have home and we would have canteen. So here it says how many students you expect to buy their lunch at the canteen on Tuesday. The canteen is 151. Now, the second part of the question talks about Friday. So that is what we are going to look at now. So we're going to look at Friday. Now, remembering that Friday is day 4 because Monday is our initial state. So that's day 0, Tuesday day 1, Wednesday day 2, Thursday day 3, Friday day 4. So that would be S4. Now, S4 is exactly the same as writing SO times T to the power 4. What we're going to do, we're going to use what we know about matrices. So we know that SO is 2, 4, 3 and 1, 5, 7. That tells us SO. And we know that our transition matrix is 0.7, 0.3, and 0.5, 0.5. I'm now going to put that into my trusty calculator, into my graphical calculator, and that will help me work out the solution. Now, on here, when I put this into my calculator, the key thing I need to make sure I remember is that I have my power 4 here. If I don't remember my power 4 at the end when I put it in, it's going to give me the same answer that I got for Tuesday. Now, I've put that into my calculator, and I've got heaps of decimal places, but I have got 249.988, so I'm going to write down 250, and then I've got 150.0112, so I'm going to write down 150 students. So this tells me, if I go back to the initial question, how many students do I expect to buy their lunch at the canteen on Friday, making sure that I remember that this is home, and this is the canteen. I know that on Friday there was 150 students who bought their lunch. Now, what we're going to do our final question, which is finding the steady state. Now, if we go back up to the success criteria, the steady state is where we try and put everything into our calculator, and we're going to put our transition matrix in, and we're going to try and get the same decimal place, and this will tell us the steady state tells us what the probability will be of each different thing. So this is part D. So what I'm going to do, I'm going to take my transition matrix, which is 0.7, 0.3, 0.5, and 0.5, and I'm going to take my transition matrix and I'm going to put it to the power 100. Now, what this gives me, once I put that to the power of 100, is 0.625, 0.625, and 0.375, and 0.375. Now, here we need to try and get it to identical to 4 decimal places in my columns, but actually I've only got 3, so I can't actually do anything about that. That means the numbers are already identical. And if we remember that what we're actually looking at here is home and the canteen, the probability of somebody eating at the canteen is 37.5% as a percentage, or 0.375 as a decimal, where the probability of the student eating from their lunch something they've brought from home is 0.625 or 62.5%. Thank you very much.